what you're going to write down at the top, we're going to use the distance formula for two things. It's used to find the distance slash length. So anywhere you want on this page, the distance formula is used to find the distance slash length. Is used to find the distance slash length of a diagonal line. It is used to find the distance slash length of a diagonal line. Used to find the distance and the length, slash length, of a diagonal line. Y'all can see the coordinate plane, right? Pretend that looked prettier. I tried really hard, but here it is. In 1.2, it would say, are these two segments congruent? In order to do that, we needed to know the length. When it looked like a horizontal line or a vertical line, what could we do to find the length? Count the boxes. 1, 2, 3, and we'd say the length is 3. 1, 2, 3, the length is 3. However, when it is diagonal, you cannot count boxes at all. You have to use the distance formula. You'll use that in this section, and you will use it in 1.4. Okay? So anytime you have a diagonal line, we have to use the distance formula. Okay? So what you're going to do is, before you write down the formula, don't write anything down yet. This is the official formula. Here's what I'm going to tell you. I have a math degree. Do you see how it says x2, x1, y2, y1? In the geometric, algebra 2, any of these high school classes, it is unnecessary to do x2, x1, y2, y1. You can do x1, x2, y1, y2. Here's what matters. The front of the parentheses, x1, y1, they should come from the same coordinate point. And the back of the parentheses, x2, y2, should also come from the same coordinate point. So when you write this down, you can write down your preference. But in class, I'm going to do x1, x2, y1, y2. Okay? Go ahead and write it down, and you'll want to make it known on this page, so probably put like a highlighted box around it or something so that you can find it. This AB, does anybody remember what AB without a line above it means? The length of AB. Okay, so the length of AB, because in this picture, AB is a diagonal line. The other parts, so you see a triangle. The other parts, when you get into higher math, which I assume that you're going to do, you're all honor students here, they'll do this thing called deriving, D-E-R-I-V-E. Basically, a math teacher will teach you why the formula is what it is, because all the formulas you know, like this formula actually is very similar to the y1 minus y2 over x1 minus x2. Y'all know what this formula is? No? It's the slope formula to find a slope of 2 points. Okay. So, do you see how it's the same, like y2, y1, x2, x1? They all come from the same thing. Okay, so in college someday, they'll show you why the formula is what it is. I personally don't care to teach you, but teach you that. If you want to know, we could hang out after school. We could talk about it. But I think you believe me. This is the formula. So, we're going to use it on these two problems. So, the first thing I want you to do is write down the formula. While you're learning it, it is super helpful to just write it until you memorize it. x1 minus x2, y1 minus y2. And then I write what I call the skeleton of the formula. It's just a really nerdy reason why I call it. I'm not going to tell you. But I call it skeleton. This is like the bare bones of the formula. The radical, the square, the minus, the plus, they will never change. What will change is what we plug into the formula. So I always write it like this. Whenever I start a problem, I just write the radical, your parentheses, whatever. It does make a face. Minus, plus, minus. I'm going to tell you the number one thing people miss are the signs. Minus, plus, minus. If you don't see the face, it looks like a jack-o'-lantern to me. I don't know. Or like one of the emojis. However you want to remember it, you do you. But with one color, so you could do one of two things. If you had colored pens, you could use different colored pens. But if you have a highlighter, that's perfectly fine. We are going to plug in our x1, which here would be, what's my first x? -6. We can label them. So my x from my first coordinate, my y from my first coordinate, my x from my second coordinate, my y from my second coordinate. You can label them. So my first x is -6, and my second x is 5. So this is why I said you can have a color. You could highlight the numbers and then highlight where you got them from so that you can see where you plug them into the formula. So we've plugged in both of our x's. I'm a very visual learner, so I'm a very visual teacher. It probably annoys the virtual students because they can see when I zoom in, when I pick a different color and I pick all the colors, it probably bothers them. But I'm very visual. I just like my notes to be colorful. We're going to plug in our y1 next. What is our y1? 3. And then our y2 is -2. So before we do anything with that, I'm just going to explain how I check when I walk around the room. When I want to see if you've plugged everything in correctly, remember that the front of the parentheses should be x1, y1. So it should be one coordinate point. Is -6, 3 a coordinate point? It is. It's the first one. Is 5, -2 a coordinate point? It is. Okay, so that's one way I walk around and check. So from here, you'll want to remember PEMDAS. Please excuse my dear Aunt Sally, right? So what does the P stand for in PEMDAS? Parentheses. So you'll want to combine inside of the parentheses. So in the first set, we've got -6 minus 5, which makes -11. In the second set, what does this minus minus do? Becomes positive. So what is 3 plus 2? 5. All right, so then from here, you only have 4 function calculators, meaning you don't have a squaring button. Does anybody know how you square without a squaring button? Multiply by itself. So here is the caution tale of this. -11 times -11. What is a negative times a negative? Positive. And then 11 times 11 is 121, right? We don't need parentheses after that. 121. Okay? So make sure when you square, it should become a positive every single time because a negative times a negative is a positive. 5 squared is 25. 121 plus 25 is 146. You would use this in your calculator. If you have a 4 function, it does have a radical button. Not all of them do. So if you needed it for a quiz or a test, you would raise your hand and I'd walk over and I would hand you one that has a radical. So if you want to take out your calculator just to check. On these calculators, sometimes they make you do the number and then the radical. I know that on the scientific they did radical the number. Try it both ways. We're going to round to the 10th, which is 1 decimal place. What is the square root of 146? 12 point what? What comes after the 0? 8, so 12.1. I think for this section, it does have both answers for your homework purposes. Tomorrow, you're going to do an activity with a partner, and I'm pretty sure the answer key has decimals. Okay? Any questions on the first? Okay. The second problem Obviously, what's the difference between the first and second problem? This one doesn't have the points just labeled for us, right? We've got to label them. So we can label them one at a time. We can label this one down here first. So starting at the origin, do I go left or right? I'm trying to make it to this point. Do I go left or right? No. So what number represents going nothing to the left and nothing to the right? 0. And then do I go up or down? Down how many? Yeah, -5. So 0, -5. Then we'll label the other coordinate point. From the origin, am I going to go left or right? To the right, how many? 5. So +5. And then we'll go up or down? Up 1. So for these purposes, you'll want to label x1, y1, x2, y2. I'm going to do left to right because we're in America and we read from the left to the right. So I'm going to call this my first coordinate point, and I'm going to call this my second coordinate point. You're not wrong if you did it the other way. It doesn't matter. We're going to write our formula. We're going to find the distance. So again, until you've fully learned or memorized the formula, I would write out the formula. It does help you slowly memorize it instead of cramming it in before a quiz. All right, so what's my first x? 0. And then my second x, what is it? It's 5. It's +5. My first y, -5. And my second y is 1, yep. So simplify in the parentheses. 0 minus 5 is, -5. -5 minus 1 is -6. -5 squared. What's -5 times -5? 25. -6 times -6. 36. Add them together. What do they make? 61, which is equivalent, round to the nearest tenth. 7.8?
Yes.
Perfect. So both technically are the answer. You just need to read the directions. If it doesn't say, you can do either one. But if it said round, you would need a round. Okay? There's one thing on this page. We'll come back to it, actually. What you're going to do is flip to the white on the back. We'll talk about this. What I want you to write as directions, so just on the back of the notes, find each segment length and tell whether the segments are congruent. So the directions, find each segment length and tell whether the segments are congruent. You have one question on your classwork like this. Find each segment length, tell whether the segments are congruent. So this is exactly like in 1.2, except for there's no graph and they're not going to be horizontal and vertical lines. So in order to find the length, we will have to use the distance formula. So you want to write down the points. Segment AB, here are our points, and segment CD, here are our points. So you want to write down the points. The graph is just for visual aid at the end. Okay. The graph is for the end. So here's what we're going to do. We're going to find the distance, the length, same thing, of each segment. Okay? So, starting with AB, we're going to write, this is a helpful way to label what you're looking for. So we're going to find the length of AB. So I want you to write capital A, capital B, and then you're going to write the distance formula. So the AB is really just so that we don't have a bunch of distance formulas and then our answer gets lost on the page. Okay. So we're going to start. We're only looking at A and B. So we're only looking here. Okay, so what is my x1 going to be? 0. And my x2? -3. What happens when I plug in that -3? Becomes a positive. My y1, 2. My y2, 8. Alright, then parentheses. 0 plus 3 is 3. We're going to square 2. What's 3 squared? 9. The other set of parentheses, 2 minus 8 is -6. And then -6 squared is 6 times 6. 36. I know we had 5 months off with Corona. So 9 plus 36 is 45. And then the square root of 45, 7 point, nope, it's not 7 point, 6.7? Okay. Oh, don't circle that. What am I doing? So we just found the length of AB. I'm not going to have enough room to do both. So I'm going to erase. So make sure you've gotten caught up. Am I okay to erase? 6.7. So the length of AB is 6.7. We need to see if the length of CD is also 6.7. So now we are looking at CD. So we're going to find the distance, the length of CD. Then our distance formula. All right, so what's our first x1? -2. And our second x, 0. Our first y is 2. And our second y, what is it? -4. So when I plug in that negative, there's a negative negative, which makes positive. All right, what's 2 minus 0? -2. What's -2 squared? 4. 2 plus 4 is 6. 6 squared is 36. Add them together, you get the square root of 40. So we can already see where this is going, right? And the square root of 40 is 6.3. So the length of CD is 6.3. So are they congruent? They're not. They're pretty close, but they're not. So if they are not congruent, state which segment length is greater. So which one is greater? AB. So we're going to write AB is greater than CD. AB is greater than CD. If they're congruent, you write the little congruent symbol. I'm going to plot the points just so you can kind of see. 0, 2, here's A. -3, 8. Here's B. -2, 2. If you want to tell me the points, that would be good. What's D? 0, -4. Lovely. All the way down here. Sorry, my graph wasn't big enough. It is what it is. They look pretty close to it, and obviously D may not be proportionally correct. They're very close in length. That's why you couldn't just graph and then say yes or no. Yes, sir.
Would you? So that one you did not put the lines with them?
Whenever you're saying length of, you don't put the lines. Is that what you mean? Yeah. Whenever I'm referring to their length, you don't put a line above. This is a very good question because next week we talk about angles, and there'll be parts of the quiz that will say like segment AB is congruent to the length of AB equals. So whereas this part is asking what segment is AB congruent to, whereas this with no line above is asking the length of AB is, and you'd have a number as an answer. Does that make sense? So that's why I'm trying to make sure I emphasize it. Like when we talk about angles, an angle will have a little m in front, and that means measure. So there's like something equivalent in both. So from here, we're going to take out a sheet of paper in our textbook. Oh, wait, we had one more thing. Sorry. 1 second. You had something on the first page, right? Or the front page. What were the letters? A, B? And then M was the middle. There's a line going through it. Is D on the bottom? Yeah, D and then C. Then they had the dashes. What did these dashes mean? What segments? So the length of AM, or you could say segment AM is congruent to segment MB. So I would say one of the problems on the test that the most common mistake I saw, I guess, was name the segment bisector. AB is not the segment bisector. AB is the segment. The segment bisector is what cuts the segment in half. So you would have named this line. You'll see it tomorrow, and we'll talk about that.